Hey guys, welcome to a new video about the Megacell Charger Professional. I'm working on implementing all the features I discussed in previous videos, and today I'm going to show you what has been done so far and how things are going in terms of production and implementing the new features in the new Megacell Charger. I'm going to show you my setup right here with this board. Let me switch to the webcam actually so you can see this bigger. So this is the new board. It's actually like 2 revisions back. I'm still waiting for the final board to come from the factory. It's going to arrive on 15 this month. It has been sent from China, and now I'm waiting for that. That will have control for discharging for every port and also for charging settings to each BQ, because right now on this board if I set charging settings to one of the ICs, so all of them will receive the same settings, so I cannot have the different charging settings on each slot. So that's on the other board. And on this board so far I've been able to implement the algorithm for constant current, constant voltage, and we have the constant resistance as well used in there. I will show you all these things, but right now I want to show you the setup that I've made to calibrate and test this properly. So you see right here, I've been working in the past with direct connection to a power supply to test the states on different voltage levels. So I would insert that in the power supply right here, and here I have a bench discharger. This one can go up to 30 amps. So I've been calibrating the discharging IC and read the values that will output. That's very precise. I compared that with my multimeter, and it was dead on, showing 1 amp there, 1 amp on my multimeter. And I found the issues that I've been having on this circuit, that the IC that I use for current reading was showing different values. That was some issues with these MOSFETs right here. These are the reverse polarity MOSFETs. If they are not opened properly, they will cause some resistance, additional resistance that's not linear to add in the code to compensate for that. So I also fixed that in the latest version, and we created that mod. You can watch the video before this one where I explained about the mod for MOSFET opening. So yeah, this is the setup right here. On this is for cell 1. On the back I removed the discharging resistors and I connected directly those thick wires to avoid voltage drop too far. But on the cell 2 I have the regular setup with the resistors on the back. So let's do some tests and see what have been done so far, what's still to do. And yeah, let me switch to desktop right here. Okay, so yesterday I was able to communicate back with the Megacell monitor. Not sure if you watched the video before this, but I said that I'm going to change most of the way that the firmware works with state machines and a lot of other optimizations that I found needed to get to the professional version. So that required to change a lot of things, so I had to re-implement the communication as well. There will be needed some changes in the Megacell monitor as well. I will talk with Martin, see if he can find the time to implement the new things, but I'm going to work first on getting everything ready, getting the API ready for communication with the Megacell monitor, have all the endpoints that the Megacell charger will support. So I will make a full documentation and send to Martin to properly add the new charger to Megacell monitor, because there will be required some settings like the chemistry for each cell. You can have different settings for charging and discharging voltage. I change a few things there because you can cap the amount of milliamps that a cell will have. Anyway, I don't want to get into details on that because that will make a very long video. Let's stick to what works for now. The charging works, and you can see that because this cell is at 4.16 volts, it will charge with 380 milliamps. And we can start charging the second cell as well. Right now the setting is with 2 amps, and it will go up to 2 amps if the cell can take it, or it's 1 amp. Let me check. So this is how I'm setting the chemistry right now. Yeah, I think it's 1 amp for charging. Charge current. I also want to make available this library in the future that will allow you to send commands to the Megacell charger. If you know its IP address, you can send JSON commands to do various things. Okay, so that's cell 2 and cell 1. Alright, let's see now. Alright. So you can see the cell 2 is charging with 2 amps. That can actually take more than 2 amps. And the new charging IC will go up to 4.5 amps, which is great for some bigger cells. It will cut down the charging time and also provide more power to the entire unit, because we'll still support the cell linking that we had before. Still have to work on that to get it done on this version as well, but then you'll have a lot of power on combining all the slots together and get like 4, 5, 6, nope, 5. So we can get up to 72 amps for the entire unit. You can charge a very large battery quite fast, but you have to be careful and make sure that the battery can take that kind of current and don't overheat. I also tested the external temperature sensors. I have made this in previous previous revisions of this board, that will have external temperature sensors connected to the XS12 connectors, and you will have an option on the API of the Megacell charger to switch between which IC you are going to use the temperature from. So if you want to charge external batteries, like with accessories connected to the batteries, you'll have an external temperature sensors that you put on that battery, and then you can test them safely without thinking that it could go overheating and you're not there. Right, so that's the charging. Let's stop this. For discharging, like I mentioned before, we have three modes. We have constant current discharging, which will keep the discharging current at the set current. For the lithium ion cells, the current will go up to 2.5 amps. For lithium phosphate, is going to go about 2 amps, because the current, the max current that the tester device will draw for each cell, it's dependent on those resistors that we have on the back. So those total about 1 ohm resistance. So theoretically you can go up to 3 amps on a 3 volt cell. But because we're doing PWM on the signal to modulate it, and we also have the MOSFET that is controlling it, it will drop a little short under 3 amps. But at 3 amps the board gets a bit too hot, so we'll cap it at 2.5 amps for all the types of cells. Right, you can see it here that it's holding it at 995 milliamps. I can actually, no, I don't have it. I wanted to pull the serial, but that will restart the device, and I don't want that. So you see that it now's got, I don't know, I probably didn't sleep very well, because my English, I find it difficult to spell some of the words. So it's 995, and we can change that. I'm actually discharging cell number 1, which goes through the external discharger. Let's switch the cells and put the more charge 1 in slot 2. So we're actually testing on our resistors and not on the external discharger. That's another thing that I want to show in the future, that you can put your own resistors, make a small mod on the Megacell charger. You remove the resistors that we placed in there, and then you can put a larger discharge module, like the bench discharger that I have there, and then you will be able to discharge up to 5 amps per cell. The limit is going to be at 5 amps, 4.8 I will say, because the INA 219 uses a shunt resistor that's set up to go up to 5 amps. I didn't put it larger than that because that will cut from the resolution I get to to measure the current. If it's going to get to 10 amps, for example, I will have less resolution on showing the milliamps that goes into the cell or goes from the cell, goes out from the cell. Okay, so I switched the cells, so we're in slot number to with the cell that has more voltage, and let me set that to discharge current 2 amps. You see, you get a success message back from the device saying that the setting was applied. So you'll see it ramping up to the set current that I put in there. I created a PID algorithm for handling this on each cell. So each cell will have its own PID controller that will make sure that the current or the voltage it's kept at the setting that we put in there. The way this works is similar to what happens with your car when you put it on autopilot for not the self-driving, but autopilot on keeping your speed. Yeah, it's the speed control. I think it's called on most of the car. You keep it at 90, for example. And the car will check the speed and adjust the throttle, so it's kept even when you go uphill. It will try to match that speed. So that's what actually happens on each cell. We have this PID controller that will check the current and adjust the PWM signal on the discharging MOSFET to give the proper resistance to keep the cell at discharging with 2 amps. I don't have actually installed a cooling fan there, and it gets quite hot. It gets hot. Yeah. So you will be able to change this on the fly. I will work on doing the same things for charging as well. On discharging, I don't have a problem right here setting the different discharging rate. But on the charging, I have to stop the charging before applying the setting, because the BQ doesn't like the charging I see that I'm using. Doesn't take in the new setting if it's already in the charging mode. Yeah, so I'll have to do some tweaks in there. My plan is to have this working so you can adjust things on the fly. Don't restart your whole process because you changed the setting. It will show you differently on the graph, but if you're testing some large cells and you want to give it more current for discharging, you should be able to tweak that. Right, so this is the discharge mode is at constant current right now. The constant voltage can be switched in the following way. So we have the discharge mode set to 0. I switch it to 1, and I have a minimum voltage of 2.8 volts. This is the voltage that I want to discharge a cell to, for example. If I do this thing, the Megacell charger will say, okay, my target voltage is 2.8 volts. I will add all the discharge power that I have to that cell until I reach that voltage. If your voltage still is above 2.8 volts, it will keep discharging until it gets to 2.8 volts. And when it's at 2.8, it will start ramping down the current for for discharging. So this way you will discharge the cell as fast as you can, as fast as the testing device can, and also it will ensure that the voltage doesn't drop lower than this. This is a quite useful function when when you're setting the voltage. That's another thing that I want to explain. Let's get back to discharge mode 0. So when you're discharging a cell, you want to not discharging. I wanted to say for the storing a cell, store discharging it, because sometimes you want to set the voltage to 3.7 volts on your cells, and depending on the voltage your cells are at, if they are above, you have to discharge them to reach 3.7 volts. So I did the following thing on the store discharging feature that we have. It will discharge it with the set current. So the set current, for example, in this chemistry setting is this one. It's 1000 milliamps, 1 amp. So it will discharge it with 1 amp. If it goes below the 3.7 volts, the store voltage, it will switch the mode to constant voltage. It will set the constant voltage to 3.7 because we want to store it at 3.7, and it will start lowering the current until it goes under the current for charge termination. I use the same parameter because I consider that if you want to finish charging at a set current, your discharging current will be similar. If we'll have the request in the future to terminate discharging at a different current, we might add it, but for now I think it will make things simpler, less settings to transmit to the charger and for the user to set as well. So in this case, if I go to store, we might have to change this because it's not just store charging. The device will check whichever state it needs to go in order to reach the storing voltage. And the way this works, I send it to a state where it checks the voltage. If it's above the store voltage, I have to discharge it. If it's under the store voltage, I have to charge it, and then it decides what needs to be done. So in this case, it decided that it needs to go in the store discharging mode. And like I said, it will discharge with 1 amp or whatever current I put in there until it reaches 3.7. When it drops a little, 3.68 for example, it will switch the mode and go in constant voltage. I think that's going to be very useful because I discharge this cell at 3.7 volts. I charge it for a little time, but it reached 3.71 volts, which is great. In the previous version, you will see like 0.1 voltage drop when you will set the voltage, because it's terminating the discharging at a set current. So like if you had discharging with 500 milliamps, it will discharge with that. It doesn't adjust the discharge rate to make sure you keep at 3.7 volts. So that's going to be useful for setting the cells at a certain voltage and make sure it's kept there. And then you can see if the cell has self-discharging more efficiently this way, because you know you left it at 3.7, and then you'll see that it drops up 3.5, for example, or 3.4. Then you know, okay, something might not be good with this cell. All right, so I think I covered most of the things about the software. Let me check. Yeah, that's most of the stuff that's done to right now. Let me check my tasks right here. Yeah, I added a state that's called cooldown. Uh, I set it in the following way. If a cell reaches a temperature above the threshold, let's say 45 degrees Celsius, it will go into a cool down state. Charging and discharging will stop, and then it will wait until temperature goes 10% below that threshold and allow charging again or discharging. I have a threshold of 3 tries on this. If the cell goes constantly above this temperature, constantly, if it goes more than 3 times above this temperature, it will call it a failed charging or discharging. So that's the cool down state. I implemented the dispose as well. That's going to do the same thing with discharging it to the set discharging like 1 volt. I think 1.5 volts was for lithium ion. It will discharge it there and switch to constant voltage to make sure it's fully discharged. The store voltage I talked about. Calibrated the device. Yeah, about calibration, I told you that I got the temperature sensor. With that temperature sensor, I also got a second wire for voltage reading on external cells, and that voltage reading is done by a second ENA 219 IC that's used just for voltage, because in the previous revision, I thought that I can just switch the channel for reading voltage and current, and that's going to work. It did for voltage, but it messed up the current, because the resistance is very fine when measuring voltage drop over the shunt, and it was adding the wire resistance that I have on the external wires, and that created a larger current shown by the ENA. I could have done something in software to compensate for that, measured the voltage drop that I get on the wires and compensate with the resistance, or calibrate it some way. But the problem was that it was capping it when I had 3 amps charging, for example. My external current reading was showing me about 5 amps. So I will lose the resolution that I should have for measuring current, and I will also lose the maximum that I can go with. So software was not going to cut solving this problem. Like I didn't have any way to make it properly work. So I added a second ENA 219 just for voltage reading on the external accessory. This allows me to measure the resistance of the wires, because I compare the 2 volts, the volt that I get on the board and the volt that I get reading directly on the cell. Then I measure the voltage drop that I get on one wire and compensate for the second wire that we have. The only downside is that both wires will have to be equal and have the same thickness in order for this algorithm to work properly. Otherwise, it will show you a slight difference in voltage, and the voltage drop is not applied properly. Because I didn't do, so right now it's 3-wire measurement, and the software is doing the compensation for the 4th wire. So it's not fully 4-wire, like hardware 4-wire, because I would risk damaging the components if you put the cell in reverse. I could have done just that by connecting another wire for the ground, but if you put the cell in reverse, it will damage the INA and also cause the BQ to overheat, because it was drawing the current, and with the risk of damaging the device, I did not add that. You will need a lot more components to make this safe. Some relays. If you hear your multimeter for ESR reading has a small switch inside, I would have needed 16 switches on the board, and also a way to control them, to turn this on and off, and then you have the current limit that each switch will go. It's not easy to make it. It would have added to the hardware price and also the complexity of that. So I had to lose the 4th wire and compensate for that in the software with the voltage drop that I get on on the positive wire. I think it's going to be a little too technical, but I know that some of you understand what I'm trying to say, because this problem have been raised in the past about the voltage drop on the cell, and most of you know what you're doing in terms of testing the cells and understand how this process works and how it should be implemented. So yeah, that's with the second INA. That was something that I did a few days ago. I sent the revision to. I modified my board. I placed a second INA IC on the back with some wires. Let me actually show you that. Let me see if I can do it without stopping the process. So let me switch first on desktop. All right, I just saw your message, Brian. Thank you very much for ordering. Yeah, there's not enough light. Let's turn it this way. Hopefully I won't short circuit anything. So the green thing right here, that's the second INA. You see some wires driven there. That's the way to do it when you want some fast prototyping done and you want to test things and don't want to wait until factory sends you the new board. That's why some companies that are developing a product will move to China, because they have fast iterations on the hardware. But I'm not one of those companies. Only flying to China will charge a few $1,000 living there. It's an entire thing. If you want to take family, it's totally entire thing. So I'm stuck with this kind of changes to keep things going fast and don't wait, because I've been working on this, and while writing the software, I found this issue like with the voltage dropping that was caused by switching on INA, and I had to update the hardware to support the new feature. About the hardware, let me actually open the Altium because I also have a few other things that I want to show you there from the last video. And let's switch to desktop. Yeah, I said that I'm going to open Altium. While Altium is loading, I want to show you the changes that I've done to the rackable version of the Megacell charger. That's going to be the metal version. We're building it in here because it will make shipping less expensive if we produce it here in Romania. Let me hide this rack so I can go around properly. This will have 12 volts and 40 amps power supply inside. And these things right here are going to be used for the external temperature sensors. Those will be like springy things that will keep a small pressure on the temperature sensors to align to touch the cell properly. So here we'll have the positive side and the negative here. I updated the holes for the XS12 connectors because this is going to use the XS12 connector for the accessories as well. Alright, let's look inside actually. Alright, so this is how it's going to be laid in, or how's the layout inside. This is a small network board. It's a wireless module that is going to connect to the Megacell charger, and then output Ethernet connector. So the way this works is I set it from here, so the Megacell charger connects directly to this module, and you just plug in the Ethernet port into this module here, and you have direct connection to the Megacell charger. So this is like an access point that communicates directly with the Megacell charger. Because they are in close proximity, you won't have the issue of getting disconnected from the Megacell charger through Wi-Fi. And in future version we'll have the the direct Ethernet connectors, but that's when we switch to the ESP32. So Altium also loaded, but let me finish showing what's up with this design first. Here is going to be the display. For now we'll keep the small display. In the future, when we switch to ESP32, we might upgrade the display as well, but we'll see in the future. Right here I have the place for 2 buttons. Yeah, that's another change. I will make the reset button that's currently on the device, that's on the plastic case as well. I will switch that to a function button as well, so you have 2 buttons to go through the menu. A lot of people complain that they will hit the reset button unintentionally, and that's not very useful placed in there. So I thought to give it a proper use. We'll still have a reset button that's next to that one, but you'll have to drill a small hole and use a pin to push it when you want to reset it. But yeah, you'll have 2 buttons, 2 function buttons to go through the menu, because I want to expose a lot of the settings that the Megacell charger can do. Not a lot. I want to expose all of them so you can use it properly when it's not connected to a computer as well. So you can set the current for charging and discharging. You will set the chemistry for cells and all the things. It's going to be some work to get the menu, and probably I will do it in after we release it, so I don't stall on releasing. You will use the Megacell monitor until that's done, but in the future this is on my to-do list as well. So right here I have the power button, and I actually have it. I think I made the video a few days ago showing the buttons. So this is going to be the power button. It's with LED. It's a push power button, and this one is for the function. So this is the function, and the second hole right here is going to be an USB connector, and I will tell you why I want to do that as well. Let me show what type of USB connector I want to add in there. Let me log into WeChat. So I will have this kind of USB connector added to the interface, and that will complete the functionality of the Megacell charger. The reason I want this USB is not just that you can monitor or write firmware directly to to the device without having to open it, or without having a connection to it already. So it will help us at the factory when we write the firmware first. But in the future, I want to make this USB work with this kind of device. So you have the ESR meter connected somewhere, and then you will have a slot that that's used for ESR reading. Let's say you put it on slot number 1. You have this connected as well, and this communicates directly with the Megacell charger. I could make a state where the ESR, after the measuring capacity is done on the device, you can start the process of ESR reading, and that will this will be connected to cell number 1. We could have an external accessory that connects to that. We'll see how that works, or we can just have a connector up and down on on slot number 1, and when we start the process of ESR reading, it will automatically test it for cell number 1 where this connects, and then you start getting the cells from slot number 2, place it in slot number 1, and so on. And then it will append the data that we have on the ESR, on the AC ESR reading. Because I've been working on and I finished working on that as well, on the current voltage drop that measures the ESR of the cell. I got it quite accurately for the cell I tested with, but that will depend on the cells and their capacity of discharging. Because on the big cells, on the 50 amp cells, lithium phosphate, when you drop the voltage, when you apply a current of 1 amp, that doesn't do very much to the voltage of the cell, and we don't have too much voltage drop to measure the resistance of that cell. So voltage drop measurement on those kind of cells, it's tricky doing it with Ohm's law, because you have to have a higher voltage current draw to have a voltage drop that you can measure properly. So on those kind of cells, this will be very useful using the ESR. For most of the people, the re-implemented version of ESR reading should work fine, especially when you're using it with accessory, with external accessory, because it's going to compensate for the voltage drop, and I'm measuring directly on the cell. That should work fine. But for those that want to get a step higher and make sure they can measure with the ESR, this USB connection will be pretty handy. I look forward to develop that and put it into practice, because I think this is going to make it a complete. Maybe we will ship this kind of device with the LCR. Yeah, I think it's LCR, not ESR. LCR meter inside, because these are complicated devices inside, and to recreate this into the Megacell charger and have it for all 16 cells, it's going to be a lot of work to do it. I'm not saying it's impossible, but I think it will be time placed in the wrong thing, because these already exist. I just have to interface with them and implement it with in some way with my device, so we can make use of this kind of feature. Right. So I think that's all about the case. So power button, USB slot right here, function buttons. I didn't added a reset button. I have the access to the reset button wires as well, but you can just power on and power off the device. Don't have to reset it. It's basically the same thing. So I did not find the need to add the reset button. Not only that it adds a cost, but you'll have a button that you never press, because you just power it on and off, and that will also reset the the board, the Ethernet board as well. So that's all for this. Let's switch to Altium Designer and show you the changes on the PCB. Alright, I switch to 3D mode. Okay, so you can see I showed it in the past as well, but this is the version. The new Megacell charger will have the option to hold two ESP devices, ESP8266 on the front and ESP32 on the back. We're not going to place both of them at the same time. We could probably have that and have them communicating via Wi-Fi, maybe connect with the ESP32 to the ESP8266 via Wi-Fi and have them running different things, but I don't think that's going to be the case, because the ESP32 is much more powerful, has more memory and also more pins to connect to, and that's why I could add this Ethernet shield right here. So this is the connector that's going to be used for connecting to Ethernet. It's a LAN 720 or something like this, I think it's called. Let's see. No, it's LAN 8720 module. So this is a module that's already there on the market, and you connect it to the ESP32 user library, and then you get Ethernet access to the ESP, which is great. It will cut down the needs to do the Wi-Fi connection. And also when you use large setups, if you have a factory or something like this, Ethernet is the way to go, because Wi-Fi will cause all sorts of issues. But for smaller setups, Wi-Fi works fine. But I wanted this to be there so I can use it. We're not going to populate the ESP32 and the connector right here, but I wanted to have this on this revision so I can keep working on this without the need to create a new PCB. And yeah, that's the LAN controller right here. You can see that I have the mod for controlling the MOSFETs. This is the LM IC. Okay, right here I have the ICs for controlling the charging and discharging. And here I switch. I had a 2-pin connector right here for the buttons, but I switched to a 4-wire connector, because I added the extra switch as well, and also the reset button as well. That's not going to be used, but it's there. If other people want to get that reset button from there, you can just connect to the wire and we'll have it. Right here I added another 2-wire connector for the 5 volts. That's going to be output to this board right here. So we have just one loop, don't have to add another 5 volts just for this. I wanted to output it from the Megacell charger, and this will keep things tidy inside the box there. I just drive a wire and I lose the 5 volts. It was 22 to 5 volts there, a DC to DC. All right, so that's why I was saying that when you develop things, when you start developing the hardware and working on the software or working on this case, because this connector got there because I was working on the case and I said, oh, a wire from here to there will be nice, let's add it, and sent another revision to the factory and say, no, use this one, don't use the previous version. I got to release candidate 10. That's how many revisions I've done on this board since I started, like 3 months ago, 2 or 3 months ago, I started working on this. So yeah, right here I added the function button. It is going to take place of the reset button, and next to it I added the actual reset button. You'll have to drill a small hole so you can access with a pin, press it if you want to reset it and don't want to disconnect the power supply or something like this. It's going to be hidden so you don't hit it by accident anymore in the future. That's another feature to add it on the list. But this is the way you do things. You iterate over things, see what works, what didn't work in the past, what pissed people off, because I had a lot. It was not just one people that asked me or told me about that reset button, and my solution was to use a small cutter and cut down the button so it doesn't go up. It's not even my solution. I think I said that he can remove it, but the client actually cut it so he can still press it, but not intentionally hitting it when you place the cell on slot number 9 or go with the hand above it, because that will ruin your day, or part of it actually, because if you have a complete capacity test in there and you reset the device, and things will reset in Megacell monitor as well, and you'll have to redo that test. But anyway, it's these small things that needs to be polished in order to get a device to a certain level and have it field tested, because that's the way you go. So yeah, right here it will be a big connector. It's 7 by 2, so it's a 14 pins connector. I can actually show it. Where I have it, Yeah, I have it in this bomb right here. So yeah, this is the type of connector that we're going to use. That will plug in directly in here. The nice thing is that if some people right there out there want to develop on this, they can put their ESP32 right here and implement the functionality in there. It's a lot of work, as we spend a lot of time. Martin spent a lot of time on the firmware, and I added on that as well, because I did rewrite most of it, but I knew what had to be done, and I looked through the past code, see what was implemented in there, and how to redo that, because there's a lot of work on getting things a certain way, getting the architecture, and when you do a second iteration, you'll say, okay, I have this mainframe. You have the whole picture in your head when you look at the code, see all the functionalities that needs to be implemented, and then you can find other ways to do it better. But to get to that picture, it took time and also iteration. So you can develop on this if you want. You can put your own code. Nobody will stop you to do that. But yeah, I think it's not worth the time if it's already done, just for the sake of doing it your way, because there are some people that want to have their own version, have their own software that works, including myself as well. I don't blame others for this, but I do it for a purpose. I do it to develop this device, not just for fun, because you can do it for fun to learn some things, but if you want to use this properly, you'll have to spend a few weeks at least to get it to a usable state. I've implemented a lot of algorithms that will smoothen the voltage reading. I was documenting myself about how the voltmeter can get those smooth reading, and that's using some smoothing algorithms like EMA, which is exponential moving average. That will make your voltage more stable when you read it. Don't fluctuate that much, because you have a smoothing value, an alpha value that will make the next reading that you add not influence it by 100%. It will influence it by 10%, for example. And if you get multiple readings that are 4.5 volts, for example, over time you'll get to 4.5 volts. But that happens gradually, and you'll not see that kind of spikes, because that's not an error on implementing the hardware. It's just how voltage reading works. Sometimes it might show you a few millivolts above, depending on the current, depending on a lot of factors. So there's the software job to smoothen that values. I did the same for the temperature, because temperature was also showing these kind of values. You will get a smooth line and then bump to 1 degree above and then go down again. So that's getting smoothed out on the hardware. It will create a small delay reaching that temperature, but that's 2 or 3 seconds. That's not going to do anything to the stopping process. It will average the values, and it will reach 50 degrees 3 seconds later. That's nothing. Okay, so yeah, I I said it in the past video as well, that right now the new version of Megacell Charger will support from 5 volts to 12 to 16 volts. I'm using a 12 volts power supply right here. This is going to drop the current that's required to be transferred by the wires, and also the PCB will handle that easier, because there's not that much current going through the PCB to get to the charging ICs, and that will make things more stable and also make it easier to do larger setups, because there are some 200 amps 5 volts power supply. You can hook up to 5 devices, and then you can fully use the Megacell charger. It still works with 5 volts 20 amps power supply, but you won't be able to use the 4.5 amps per cell, charging all 16 cells at the same time, because you need like 60 amps, I think. So if you use 4.5 volts for 4.5 amps multiplied by 16, you need a 72 amps power supply at 5 volts if you want to. Let's multiply by 4.2. You need a 300 watts power supply. So roughly 60 amps, but that's on the limit. The power supply, usually when you're using a power supply, you should be around 10 to 15% lower to the absolute rating on that. So like an 80 amps power supply will be better fit at 5 volts. But if you are using 12 volts, things change, because you need 300 watts. So 300 watts divided by 12 volts, you need just 25 amps to achieve the same power, to deliver the same power. And at 70 amps going through that PCB, I don't think it's going to handle it very well. That's why we made it to work with 12 volts. You can use 5 volts, but you will have to cap the current to the to 1 amp per cell, like it was in the previous version. For most of the setups, most of the testing that you're going to do, you should not go above 1 amp charging. But if you are testing larger cells, you might have to use higher amperage, higher current for charging. So yeah, that's about it, guys. I will not send you to the Deep Cycle Power site to pre-order this anymore, because today I'm going to stop that. It was stopped a week ago, but because I had to send another iteration to the factory, I could open it, so I did open the pre-order. A few more clients jumped in when I actually opened it at their request, because they asked me if they still can go there, and I didn't want to lie saying no, we stopped this just to keep things, or to force them to order in the future at a higher price. If we had a small delay on the factory, I got advantage of that and let other people in with the pre-order as well, because there's no harm in adding an extra 10 to 15 boards to the factory. If I have the money to give it to the factory, why not doing it? And also save people some money, because this is not just about making me money. This become a personal project that I want to develop it to a certain level, and maybe in the future will actually make us some money, not just me, the team as well. Martin, that worked a lot on the Megacell monitor and on the firmware, and also Mihai, that designed the first prototype of this board. We'll still partner on this, and I consulted him on the new design, because I know some things, but he knows a lot more things about electronics, and so we combine this with my skills to design. Is not to design, is to use software actually, and the patience of getting things done and implement them properly, test them, and all that. That I have to give me some credit for, because there's people that can design things, but if they don't have the necessary patience or they don't believe in that project, they will not spend the time, and that potential is never placed in something, or not in this device, because to keep someone interested in developing this for a few years, it's either something personal or it's a lot of money in this. Right now it's not a lot of money in Megacell Charger. It's all right to keep developing it and not close it somewhere and store it somewhere and forget about this. It might be more useful in the future to more people, and they will start using it, hopefully. But if it's not, I'll have a nice tester right here that I can use myself for testing my batteries. So that's about it for this video, guys. I showed you all the things that I've been working on. Things are closing in, starting to get things working with the software as well, with the Megacell monitor. I will keep working. I have to do the workflows, the measure capacity that will fully charge the cell and discharge it, and then charge it to store voltage. That's going to be another state machine that's monitoring the states that each cell is in. So it's like a macro manager state machine that is going to do the things with the cell. I started getting low on the memory on the ESP8266. Martin actually told me this, okay, good luck with that, because you're running on a small memory. And I started just barely fitting in the past days with all the extra things that have been added. I think there's still room to optimize some of the functions using pointers and all that to avoid filling in the memory. But yeah, it's kind of interesting being restricted, because on computers, like developing a software on a computer, you have, I don't know, 32 gigs of memory. On ESP you have 2 kilobytes that you can use most of the time. Like that's insane when you're thinking about the memory for each thing. When you want to create a JSON communication and you see, okay, I have 700 bytes, 7,000 bytes, it's not going to fit because I don't have enough memory on that. So that's why I also added the ESP32 that has a lot more memory. It has Bluetooth. It can handle the Ethernet as well. But I don't want to stop developing the software now and wait another 1 or 2 months until the ESP32 version is fully tested and have all the functionality working fine in there. We'll finish first the ESP8266. We'll make it work. It's It's going to take a bit more time to optimize it and find which libraries are not useful and remove all the things that are not needed to free up some memory. So yeah, again, that's it, guys. I hope you will find this useful. I know it will be useful for me, at least, to look in the future, say, okay, I was doing this and that. But if you are finding this useful and finding this kind of updates useful as well, hope you enjoy them. And yeah, I want to keep things transparent, show you what I'm working on. I'm not just trying to raise some money for something and don't put the work in it. I put the work in it. I want it to be a nice project, a nice device to be used by people in testing this, and hopefully we'll get there soon enough, so it's not going to take another 4 years to fully develop this. It took 4 years since we started this project, but there have been a few hiccups with the pandemic and stuff like this that stopped. This should have taken about 2 years to get to this process right here, but like in regular times, and not insane pricing for shipping and components and stuff like this. Yeah, I'm going to stop this streaming right now, and we'll keep you guys updated when I'm going to receive the new boards. It's going to be hopefully on next week, on 15 September. I will test the new features, and then I will start producing the new boards. Have a great day, guys, and